One of the ways that you can tell the difference between a mixture and a compound is that we mentioned the mixture can have different amounts of the different items, whereas a compound has a formula, it's a set ratio. But mixtures can have different amounts of solute in them, and they could be more concentrated or they could be more dilute. And so when we talk about a mixture, we might want to quantitatively let people know what the concentration is. The concentration is letting people know the relationship between the amount of solute and the amount of solution. You might have a solution with a large amount of solute in it, or a solution with a smaller amount of solute in it. And so there's several different ways to express concentration. This course will focus on mass percent in this section and then molarity in the next section. So for mass percent, the amount of solute is expressed in grams, and then the amount of solution is also expressed in grams. And so out of the entire mixture, what percent of that by mass is solute? That's what we're telling people. Don't forget that we are talking about out of the entire mixture, how much solute we have. And so if you have been given the amount of solute and the amount of solvent, then you have to add them together to get the amount of mixture. This is a mistake that people often make, that they, instead of using grams of solution, will use grams of solvent. So this first problem here, we are told the amount of potassium nitrate and the amount of water. That we have 35, we're told that we have 35 grams of potassium nitrate mixed with 100 grams of water. So the amount of mixture that we have is not 100 grams. The amount of mixture, or the amount of solution that we have once it dissolves, is 135 grams of solution. So this is what needs to go in the denominator. And so to calculate the mass percent, you would put the 35 grams of potassium nitrate over the total mass of the mixture, and that would end up being 25.9% by mass. So out of the mixture, 25.9% of the mass of that mixture is due to potassium nitrate. All right, for this problem over here, you are told the amount of solute and you're told the amount of solution. So instead of water, we know that the entire mixture together is the 354 grams. So this time we are able to use the mass of solute in the numerator, 45.8 grams sodium chloride, and the mass of solution, 354.0 grams of solution, is already given to us. We can use that in the denominator and then express that as a percent. So this time we don't have to add them together. So it's important that you pay attention to what these numbers are telling you, not just grab the numbers and put them in the formula or put them in a fraction. So pay attention to what the different masses are before you calculate the mass percent. So since the mass percent is a relationship, we can use it as a conversion factor. Any concentration is a relationship and can be used as a conversion factor. So we should take a look at this. What does this mass percent mean? Remember, percent means per 100. So for every 100 grams of the solution, the mixture, we have 7.35 grams of that being potassium chloride. So this is our relationship that the concentration is telling us. What the problem wants us to do is convert. We have 327.5 grams of solution, and we want to convert that to grams of potassium chloride. So let's go ahead and express this relationship as a conversion factor. We'll put grams of solution on the bottom, grams of potassium chloride on top, and we get 24.1 grams of potassium chloride are in 327.5 grams of the mixture. In this problem, we want to go the other way. We know the grams of solute, glucose, and we want to know the grams of solution. And here is the relationship that we can use. 11.8% by mass glucose means out of every 100 grams of the mixture, 11.8 grams are glucose. So here we start with the grams of glucose. We write the conversion factor with glucose on the bottom because then that will cancel, and we end up with 27.7 grams of solution. So just a couple things to be careful of. If you just write grams and grams and grams, then the grams are going to cancel even if you have this flipped. So it does help to pay attention to what substance you're talking about the mass of. That this is 11.8 grams of glucose and 100 grams of solution, not 100 grams of glucose and 11.8 grams of solution. And another tip is to check and see if the answer makes sense, because if you flip this fraction, you are going to end up with a much smaller number. So you would have a number that's way less than 3 grams. And it's really impossible to have 3.27 grams of glucose dissolved in less than 3 grams of the mixture. So we needed to come out with a number that was bigger than 3 grams. So if you come out with a number that's way off from what you expect, then you might want to take another look at the conversion factor.